Hello friends, hi, this is Naresh. Welcome to Easy Automate, and today we will go through one of the important topic in ISTQB certification, that is equivalence partitioning. So this is one of the testing technique which we have to follow so that we come up with the required number of test cases while we are doing a test planning and when we are doing testing. So let's go ahead with this. Let me scroll down so that we can go to the section. So this is one of the blog which I have written on equivalence partitioning. Okay, I have clicked on that. All right. So before we even go with this topic, equivalence partitioning, let's understand the need, why we need to do equivalence partitioning. So when we are going through our testing work, when we are doing a test planning, there are many situations, when we have to know how exactly number of test cases are. It might possible there are large number of test cases, but you are not sure which test case to include and which test case not to include in your test plan. So we have to follow different techniques to know how many test cases are required and if we are good with those, and that will test our whole functionality which we are trying to test. So this is also one of the technique. Let's read more about this. So as it says, equivalence partitioning is used to reduce the number of test cases that is required to effectively test the handling of inputs, outputs, internal value, and time related value. So we can apply this technique onto all these fields which are mentioned: inputs, outputs, and internal values, and time related values. Partitioning is used to create equivalence classes, often called equivalence partition, which are created of set of values that are processed in same manner. So we whenever we have some inputs, and on the basis of that we need to drive some test cases. So we need to divide them into equivalence classes. We will look into detail what exactly equivalence classes means, and from every class we have to select one representative. So from every partition we have to select one representative which actually cover the whole class. Okay, so when we will look at the practical example, then we will understand it more. So for now we will go through its applicability and limitation. So what is the applicability? This technique is applicable at any level of testing. So you can apply this at any level. Can be unit testing, integration testing, system testing, or any other testing which you think of, and is appropriate when all the members of set of values to be tested are expected to be handled in the same way where the sets of values used by application do not interact. So what does it mean? For example, let's say you want to test a menu, and in that menu you have to select a font size, and font size range from 1 to 100. So when you say the font size range from 1 to 100, all the numbers are integers, and if you divide it into the classes, so from 1 to 100 you can choose any font. Even though you choose, like, font of size 8 or font of size 12, you can choose any number, and through which you will know if my font menu is working correctly or not. So that's one of the equivalence class. Okay, we will take more example after some time. So the second is the selection of the sets of value is applicable to valid and invalid partition. That is, partition containing value that should be considered invalid for the software being tested. So whenever you are dividing any situation, or whenever you are dividing your test scenarios into the classes, so you have to make sure there are a valid partition and there is also a invalid partition. This technique is strongest when used in combinations with boundary value analysis, which expands the test value to include those on the edges of the partition. So boundary value analysis is also one of the testing technique which we will learn in the next video. But for now, we will concentrate about the equivalence partitioning. So, sometime what happened that we apply not one technique, but we make a combination of one or more techniques. So here it is saying we can use that with the boundary value analysis, and it is the strongest when it is used in combination of this. And this technique is commonly used for smoke testing of a new build or a new release, and it is quickly determined if the basic functionality is working. So what does it say? It means that whenever you want to test the basic functionality of a software, whether it's working or not, you can use this technique. But with that, it also have some limitations. So you have to make sure, you are going through the limitations also before you even apply this technique. So if the assumption is incorrect and the value in the partition are not handled in exactly the same way, this technique may miss defects, and it is also important to select partition carefully. Okay, so you have to know before you apply this technique that your assumptions are correct. For example, let's say there is no menu given for the font. There is just a text box in which you have to write a font. Okay, and in that you have identified there can be two classes. One is positive, one is negative. Let's say you are taking a positive as numbers, and you are taking negative like minus. You put a minus and then a number. You are thinking about a user can either input a positive number, and user can put a negative number. So you have prepared two test cases, but somehow you forget that user can put anything there. It might possible he can put characters, and you have not set invalid partition of characters. Okay, so in this case there can be more than one invalid partition. A user can put minus numbers, a user can put characters, a user can put some special numbers. Okay, even might possible user can put zero, or maybe don't put anything and just put spaces and hit enter. Right, so you have to make sure what your assumptions are. According to that, you can only divide your scenarios into the different partitions, into the different classes. Okay, so here also it's given one example. For example, an input field that accepts positive and negative number would be a better tested as two valid partition, one for positive, one for negative number, because the likelihood of different handling depending on whether or not zero is allowed. This could become another partition as well. It is important for test analysts to understand the underlying process in order to determine the best partitioning of the value. So this is something which I have already explained. Coverage. Coverage is determined by taking the number of partition for which a value has been tested and dividing that number of partition that has been identified. For let's say you have identified 4 partition, and you have just created a test case, like you have only derived 3 test cases from that. So if you divide 3 divided by 4, then it will give you the coverage percentage. Okay. Using multiple value of a single partition does not increase the coverage percentage. So what does it say? It's saying that let's say you have 4 partition, and somehow from one partition you are increasing the number of test cases. From one partition, you took 3 test cases, so another 3 partition you took 1 test cases each. So what will happen? It will not increase your coverage percentage. If you divide number of test cases as 7 by total number of partition 4, it will not increase your test case percentage. Okay, so you have to make sure your scenarios are equivalent to the classes which has been identified, and generally we need like 1 test case for each class. Defects, what kind of defect it can find? These technique find the functional defects in handling of various data values. So I believe what are the functional and non-functional defects. So normally it's it find the defect related to the functionality of the product. So here is given one example. Let's see this example. For example, a saving account in a bank has different rates of interest depending on the balance in the account. Let's say the 3% rate of interest is given if the balance is in account is a range of 0 to 100. So if you look in the chart, from 0 to 100, bank is providing 3% interest. 5% interest is given if the balance in the account is in a range of 100 to 1000. Okay, and 7% interest is given if the balance in the account is from 1000 and above. So by looking at that, you can drive, first of all you have to drive the chart, what exactly my partitions are, what exactly my invalid partitions are. So from looking at these statements, we can come to the conclusion that if I make a chart, it will something like 0 to 100 3%, then 100.01 to 999.99 as second partition, and then from 1000 it will be the third partition, and negative will be, you know, any number which is below $0. So this is like your four partition given, three valid, one invalid. So once you are dried with this chart, after that you have to come up with your test cases. So if you see in this is a snagget of screenshot of the Excel sheet. If you see there are four partition. So from each partition you choose any number. So you don't have to choose all the numbers. You just have to choose one number. So if you see in the valid partition from 3%, like from 0 to 100, we have choose 50. Okay, from 100.01 to 99.99 we have choose 260, and from 99.99 to 1000 we have choose 1348. I'm sorry, from 99.99 to 1000 we have choose 260, and from 1000 above we have choose 1348. So these are the four numbers which we have chosen. Okay, and we have also given a negative scenario, for example -10, and for -10 we are expecting some kind of error message. So this is how, you know, you can drive your scenarios, and on the basis of this you can write your test cases. So this is how we drive all the test cases on the basis of equivalence partitioning. And when we talked about coverage, it means that, you know, for example, in this example, it's given 260 is one of the partition, which is with the 5% interest, which bank will provide. Even if you go ahead and, you know, you put some more test cases, you might be thinking, you know, I can, you may think that I can put 261, 262, 263 all, but that doesn't make any difference on the result. Even if you increase the number of test cases here, it doesn't make any difference. Why? Because all those numbers will still give you the results f5%. So why to check, you know, more test cases when, you know, our inputs are same? So that's the reason we have divided into the different classes, and from each class we took one scenario. Okay, now composing tests. So sometimes what happens that even we divide it into the equivalence partitioning, sometimes we have to look for some more scenarios, some more population. Let's say you have the same scenarios, but now what the bank says, if your age is greater than 65 or if your age is less than 65, because it says that if the participant age is less than 65, then he will not get any additional benefit, and if it is more than 65, he will get 1% additional benefit considering his older age. So with that, if you divide, if you create again an Excel sheet for those test cases, it will be something like this. So if you see, I have you know, come up with the 7 classes. So one is negative for sure. If the number is negative, you know, if the you know, age is greater than 65 or less than 65, it doesn't matter. So it will always give you a message. If the age is less than 65, then there can be 3 partition, you know, which will be. Let me just check that. Okay, so yeah, so with 3 partition for 3%, 5%, and 7%. And even if, you know, the age is greater than 65, then again there will be 3 partition plus, you know, because if it is greater than 65, you will get an additional interest. Okay, so instead of 3, 5, and 7%, you will get 4%, 6%, and 8%. So this is how, you know, even if your criteria is more than one, you can apply this equivalence partitioning and can come up with scenarios, you know, through which you can test it out your software. Okay, so from these 7 test conditions, you can entirely test the functionality. You don't have to give, you know, hundreds of test cases to test your functionality. So that's it. This is all from the equivalence partitioning testing technique. If any question, you can always put your comment in the comment section. Thank you.